Hello and welcome to my channel. In this video we are going to solve some multiple choice questions on polynomials. So in this question I am going to cover question number 7, 8 and 9. If you wish to look at the questions 1 to 6 from the Quadratic Polynomials Multiple Choice Questions, then you can click on the link here. So let us begin with the 7th one. If alpha and beta are zeros of the quadratic polynomial f of x equal to x square minus x minus 4, then the value of 1 over alpha plus 1 over beta minus alpha beta is. Now alpha and beta are the zeros of the quadratic polynomial and they have given us an expression over here. So let us start by writing the general form of the quadratic polynomial. So f of x is equal to x square minus sum of zeros times x plus product of zeros. Now in terms of alpha and beta we write it as f of x equal to x square minus sum of zeros is alpha plus beta times x plus product of zeros is alpha times beta. Now let us write down the expression which they have given just below this alpha beta formula. So they have given here f of x is equal to x square minus x minus 4. Now looking at these two expressions, we are going to compare the x terms and the constant terms from the two equations. So here the coefficient of x is minus alpha plus beta. So let us write here minus alpha plus beta is equal to, here the coefficient of x is negative 1. So if there is no number we take it as 1. So here negative 1. Now cancelling the negatives from both the sides of the equal to sign, we get alpha plus beta is equal to 1. Now similarly comparing the product of zeros, we can write alpha beta is equal to negative 4. So we have got alpha plus beta and alpha beta. Now once we have got these two values, let us come back to the given expression, that is 1 over alpha plus 1 over beta minus alpha beta. Now if we try to get this given expression in the form of sum of zeros and product of zeros, then it becomes really easy to substitute the values. So let me write down the given expression again here. So it's given as 1 over alpha plus 1 over beta minus alpha beta. Now I am going to take the common LCM between this 1 over alpha and 1 over beta. So multiplying this with beta, that is cross multiplication to the numerator and denominator, and similarly multiplying alpha to the numerator and to the denominator. Now we get here, now I am not going to touch this alpha beta because already it is in the product of zeros form. So here we get beta over alpha beta plus 1 times alpha is alpha over alpha beta minus alpha beta. Now since here the denominators are same, I can combine the numerators and write it as alpha plus beta and write down the common denominator alpha beta minus alpha beta. Now we have got the sum of the zeros alpha plus beta and product of zeros alpha beta. So let us substitute the values here. Alpha plus beta is 1 and alpha beta is negative 4. So here we have 1 over negative 4 minus of minus 4. So here we can write as negative 1 over 4 and minus of minus is plus 4. Now again taking the common LCM, so let us write here 4 over 1. So here cross multiplying, we are going to multiply it with 4 and same thing with the denominator, and here we are going to multiply with 1. So 1 times 1 and 4 times 1. So this simplifies as negative 1 times 1 is negative 1 over 4 plus 4 times 4 is 16 over 4. So the denominator is same, we are going to write a common denominator here 4 and negative 1 plus 16, combining the numerators. We get the value here as positive 15 over 4. So this is the value of the given expression. So let us see our answer is in the options or not. So we have 15/4 as our option A. Now let us move on to the 8th question. If the square of difference of the zeros of the quadratic polynomial x square plus px plus 45 is equal to 144, then the value of p is. Now they have given that the square of difference of the zeros. So if we take the zeros as alpha and beta, then we are going to take the difference of these two zeros and then we are going to square the difference. So if the square of the difference of the zeros of the quadratic polynomial is equal to 144, then what is the value of p from this given polynomial equation? Now this is what they have given, plus they have given the expression. So let me write down the expression now. So it is x square plus p of x plus 45. Now we are going to use the alpha plus beta and alpha beta formula to find out the sum of the roots and product of the roots. So let me write down the formula here. Now comparing the sum of the roots, which are the coefficient of x term, we get minus alpha plus beta is equal to the x coefficient over here is p. So let us write here p, and the product of the zeros, that is alpha beta. So by comparison we can write here 45. So here we can write just simply alpha plus beta. Let us take the negative on the other side of the equal to sign, so it becomes negative p, and alpha beta stays the same. Now here let us consider alpha minus beta the whole square equal to 144 as our expression 1, and we know that this is an algebraic expression, that is a minus b the whole square. So we can expand it as alpha square plus beta square minus 2 alpha beta is equal to 144. So this is how we have expanded the expression 1 by using the algebraic identity. Now alpha beta can be substituted over here, that is alpha beta is 45, we can just put it over here. But we do not have any substitution for alpha square plus beta square. So a little bit of adjustment or manipulation needs to be done here so that we can make use of this alpha beta into this expression. So here I am just going to make a small adjustment, that is alpha square plus beta square minus 2 alpha beta, and I am going to just add plus 2 alpha beta on both the side of the equal to sign. So here 144 plus 2 alpha beta. So if you see that way, from both the sides plus 2 alpha beta and plus 2 alpha beta will cancel each other. So this is the kind of adjustment you need to make such that the previous original expression is not getting changed. So add plus 2 alpha beta on both the sides of the equal to sign. So let me put it this way. Now we can combine this alpha square plus beta square with plus 2 alpha beta. So let me take it together. So alpha square plus beta square plus 2 alpha beta. So let me take it together and put it in a bracket. And this minus 2 alpha beta, I'll just push it ahead in the expression. And here this is equal to 144 plus 2 alpha beta. Now here alpha square plus beta square plus 2 alpha beta is nothing but the expansion of alpha plus beta the whole square minus 2 alpha beta is equal to 144 plus 2 alpha beta. So you can see we have got the given expression, that is alpha minus beta the whole square equal to 144 in terms of alpha plus beta and alpha beta. Now simply we have to substitute the terms, that is alpha plus beta was negative p. So here we'll write negative p to the power of 2 since it is a square minus 2 times alpha beta is 45 as we have got over here, and this is equal to 144 plus 2 times again 45. So here negative p square turns into positive p square, minus 2 times 45 is 90 equals 144 plus again 2 times 45 is 90. So taking the negative 90 on the other side of the equal to sign, it turns into positive 90. So we have p square is equal to 144 plus 90 plus 90. So p square is equal to, this will give us a value of 324. So taking the square on the other side of the equal to sign, we get p is equal to, when square goes on the other side of equal to sign, you get two values, that is one is plus and one is minus, and square root of 324, and square root of 324 is 18. So the p value is plus minus 18. So let us see which is the option over here. So we have option D as our answer, which is plus minus 18. So remember this small step of adjustment or manipulation, so that you are changing the alpha minus beta into positive alpha plus beta. Now let us move on to the last question, which is the 9th one. The quadratic polynomial, the sum of whose zeros is negative 5 and their product is 6 is. So we have to find out the equation of the quadratic polynomial whose sum and product is given. So sum of the zeros, let us take it as alpha plus beta. So here they have given the value as negative 5, and a product is given as 6. So alpha beta is equal to 6. So let us write down the general form of the quadratic polynomial in terms of alpha and beta. So f of x is equal to x square minus sum of zeros, which is alpha plus beta, times x, plus product of zeros is alpha beta. So let us substitute the values here. So we have x square minus alpha plus beta is negative 5. So negative 5 times x plus alpha beta is 6. So here we get x square, minus of minus is plus, so plus 5x plus 6. So this is the equation of the quadratic polynomial. So here we have option A as the answer. I hope you understood all the steps in all the 3 examples. If you know any other way of solving these examples, do comment below. And if you're liking my videos, like, share and subscribe to my channel, and thank you for watching.